So in this section, we start by adding an extra step, which is, on the previous ones we had a trig function equal to a constant. And on this problem, we have to get equations into that form first. So we're going to find all solutions of tangent squared theta minus 3 tangent theta minus 10 equals 0 that lie in the interval 2 pi to 4 pi. And it says to round your answer to the nearest hundredth place. Or, I'm sorry, thousandth place. So solution, notice that this is a quadratic in tangent theta. So I can factor it like a quadratic. So, and when I do, I get tangent theta plus 2 times tangent theta minus 5 equals 0. This breaks up into two equations, kind of like what we had before. Tangent theta equals negative 2 and tangent theta equals 5. Now I need to solve for the thetas. So for tangent theta equals negative 2, I get this triangle. I know it's this triangle because tangent is opposite over adjacent. And the arctangent, which I'm going to use here because it's not going to be one of my standard triangles, the arctangent is going to be in quadrants 1 or 4. The other triangle with tangent negative 2, the other angle with tangent negative 2 would give me a triangle in quadrant 2, which is not where arctangent is. So that's why I'm ignoring that one. Okay, tangent theta equals 5. Well, also I'm ignoring it because with tangent, you only need one of these triangles for each equation, because you're just going to be adding pi, integer multiples of pi. Okay, so anyway, this theta, this is in quadrant 1. It's 5, 1, this triangle. Rise over run. Right? So neither triangle is one of our standard triangles, 30, 60, 90, or 45, 45, 90. So that means that when I do the arctangent, it's going to be an estimate. So I get theta equals the arctangent of negative 2 plus pi k, for k in the integers, or theta equals tangent inverse of 5 plus pi k with k in the integers. Now I need to find the values of that. They don't want all of them. They just want the values that lie in the interval 2 pi to 4 pi. And to do that, you just add pi to it or subtract pi, as the case may be. In this case, I think it's adding pi to get it in between 2 pi and 4 pi. And in order to know when I got there, I estimated 2 pi and 4 pi. I just estimated to 2 decimal places because that's enough to tell me if my answers are in those intervals or not. Yeah, and then you do the same thing, add the period pi to the values of arctangent 5 until you get all the values that are in that interval. So what I got was theta equals 8.318 and 11.459 from tangent inverse of 2. And I got 7.657 and 10.798 from tangent of 5. Now I should check these. First of all, you want to check that they're in the interval, but I did that already when I found them. But you could take these and put them in the equation, and you should get approximately 0, right? It'll be a little off because of round-off error, but you should get pretty close to 0. And you can do that with each one to make sure that it actually works. And then just make sure that they're in this interval here, which they are. See, between 6 and 12, right? Okay, so that's that problem.